Hi folks, Mr. Long here. Today we're going to do some sketching with BEDMAS. So to begin with, I'll just go over the function that we're going to sketch right here. And so some things that we can think about. I see the square root there. I know, for example, that I can't have a negative under here. Okay, so I can never have a negative there, so negative 4x plus 20 must be greater than 0. I also know that nice easy square roots to get are 0 and 4. So that's what the root 0 and the root 4 refer to here. So the first thing I'm going to do is figure out what x values will create root 0 and root 4. So first thing again is to common factor that. If I common factor it, I get this right here, negative 4x minus 5. And I set it equal to 0 because I want this thing underneath here to be worth 0. So if I solve that equation, I simply get x equals 5. So the 0 root is at x equals 5. Just like before with quadratics, we had the 0 square. Okay, so x minus 5 equals 0, x equals 5. Then the other thing that I want this to be is 4. Okay, because 4 is a nice easy square root to calculate. So what I do is I set the part inside the root to be equal to 4. And then I solve it. And I do that by inverse operations. So the first thing I do is I take this 4 and I divide by that negative 4. Then instead of minusing 5, I add 5. So negative 4 goes into 4 negative 1 times, plus 5 is 4. So if x equals 4, then there's the value underneath the root sign is actually 4. Let's see if that makes sense when I go over to here. So both of these. So the first one I wanted to get is 0. Okay, 0. So if I look at this right here, I know I've got lots of writing on that. Negative 4x plus 20. So I had 5, right? Was the first number I came up with. So then I'd have negative 4 times 5. X would be 5. That's negative 20. Negative 20 plus 20 is 0. So that's a 0 root when x equals 5. Then what about root 4? Well, root 4, I need to set this negative 4x plus 20 equal to 4, which I did. After factoring, I solved for x, and it worked out to be 4. Well, negative 4 times 4 is negative 16. Negative 16 plus 20 is, in fact, 4. Okay, so those are the two key x values. Okay, the two key x values. Let's look at the straight line. Negative 4x minus 5. Well, I'm just going to go over here to a graph. And so we know that the line would look like this, right? It's a straight line. It passes through at 5, and it has a slope of negative 4, which we can see pretty clearly right here, right? So it goes down 4 and right 1. Negative 4 over 1. That's the slope of that line. Okay, and it passes through at x equals 5. So, and that's the brackets part. And remember, it's not really brackets. What it really is grouping. So that square root symbol is a grouping symbol. So here's what I know. If I sub in 5, I'm going to get 0, right? And that's obvious. If I sub in 4, I get 4. I've already done this. So what kind of a transformation is this? Well, what that does, we can see that, you know what, this is something I'll deal with this part a little bit later because it's horizontal transformation, but probably better to read it in class. So what's the next thing I do? Well, in terms of order of operations, the next thing I do is exponents, right? I have to do my exponents next. And the exponent is square root, exponent 1/2. So now I do the exponent of all of this, okay? So what is negative 4x minus 5? Well, it's 0 and 4. Now I do the square root. Square root of 0 is 0. Square root of 4 is 2. And what that does is that takes a straight line and turns it into a square root graph, okay? So that's that transformation. What's next? Well, according to BEDMAS, I need to see multiplication. Where do I see that? Right there. Multiply by negative 3. But remember, it's a y value, right? So now I go 0 times negative 3 to get 0, 2 times negative 3 to get negative 6. Since I'm multiplying, we call this a vertical scaling. Factors negative 3. So all the y values were multiplied by negative 3, but because they're being multiplied by negative, there's a vertical reflection, right? So the normal square root graph, which we see is right there, the one that goes from 0 to 4 and goes up 2, right? Well, as soon as it reflects vertically, it's going to be like so. Okay, it's going to open down like that. Okay, that's a vertical reflection. Okay, then what do I do next? Well, the last thing I do is add 6. Add subtract is, oops, that should be add 6, not 5. Add 6. So what do? I have 0 here. I add 6 and I get 6. I'm at negative 6. I add 6 and I get 0. So remember that these are y values, and the only two x values are up here. The x values never change, 5 and 4. So what I can do now is plot this ordered pair, so 5 and 6, 4 and 0. Let's plot those. 5 and 6, 4 and 0. So 5 goes all the way up to 6, that's right there. And then 4 and 0 is right there. So, and that's what the square root graph looks like, right? So it's going to go down like that forever, okay? And this right here we know as the cusp. And where is that at? That is at 5 and 6. Okay, it's a vertical reflection and a horizontal reflection. Okay, so I think, and by the way, we call that a vertical translation because the y values are added by 5. So what we're going to have to do in class is to go over horizontal scaling and horizontal translations, because that's what the straight line does. It transforms it. Okay, and so what are the graphs that I have plotted on here? Well, this is just original root x, right? I go over 1, I go up 1. That makes sense. Square root of 0 is 0. Square root of 4 is 2. Okay, and then this graph here is the final graph. Okay, so I have 3 graphs showing here. I have the square root of x, just so we can compare. I have the straight line, which is at the heart of the function. And then I have the final transformed function, which goes from 5, 6 to 4, 0. And it would keep going. Okay? All right, folks. So hopefully that helps in terms of how the calculations work and how the order of operations works. Best of luck working on the rest of these.